Hi there. So today I was going to try to, well, teach and also, showcase just how to do Newton's method for, numerical iteration, right? Which is basically just a smart way to guess and check through problems like this, which can't really be solved very simply. So basically, this is going to be a pretty quick video, I think. So this is essentially saying that the new x is going to be the old x minus this ratio here, which is, of course, just the function with the old x inputted over the function with the old x inputted, the rate of change of that, which is, of course, yeah. So let's try it with something like this, right? So x equals x minus, okay. Right, so x equals, let's say, 2 minus f2 over f prime 2. See how close we are already? Right there. So, our answer is going to be this, 1.8837387287. So, that is our new x, so, right, so, yeah, it's going to be that minus f this over f prime this, and then x equals that. So, look at that. Look at how close we got with just two simple little things there. Look at that. Right there. Just a little bit off. So let's do this, go ahead and do this one more time. Right, so we got this answer. We got x equals this minus yep. And as you can see, that may as well be the answer, right? In fact, as far as I can tell, it is the answer. I can't even zoom in far enough for it to not be the answer. So, yeah, I'd say that's perfect. And yeah, that's how easy Newton's method is, really. You just give one simple, guess that you think might be like somewhat close. It doesn't even really need to be that close. It'll just take more if it isn't that close. You just input a number and it'll, automatically come up step by step with, a way to get very close very quickly. So yeah, I hope that this could help you. I hope that, this has inspired you to learn it some more. In fact, I'm going to go ahead and use this with one more different function. Let's say you have something like sine x, log natural x. Okay. Like, hold on. Minus log natural x plus 6. What even is the x-intercept for that? I don't know. Let's go ahead and get rid of this sign, because I don't really want to have to deal with that. Pi. Okay. So we have this, and I think we would be looking for this x-intercept here. So let's input our values. So the first one we got was, way off. We're way off there. So x equals this new value here minus, take this. Whoops, my fault. Okay, just got to do that again. We're already getting pretty close, so let's go ahead and set this up so that it's directly at the, oh, right, yeah. Fx equals 0. Whoa. How How would I do this? Whatever, it doesn't really matter, but we have our x-intercept here anyways. It's plotted out, so let's go ahead and continue. We have, just copy paste this entire thing so I don't have to do all that weird copy paste stuff now. Sorry about the noise. Well, it's not my fault, but my aunt's over and she has her dog, so what do you do about that one? Okay. Already really close. We just need to get to 13.23642. Like I said, usually you probably wouldn't even pick 2 for the original thing, so you could do this even faster, but the point isn't really that this will get it super quickly. It's just that it's gonna be like the fastest way you can use, right? Wonderful. Off, literally, look at that. Look at that. Look at how close that is. So, one more run, it'll be visually just right on it. And it's going to be that fast, I'd recommend doing it until the changes are incredibly minute, because, of course, the rate of change is going to be directly affected by how close you are. Look at that. It's the interception now. Down to the 10th decimal place, so that's about as close as you can get. So, and you see how it's directly affected with every different swoop. It'll I think maybe it'll cut in half every time. I'm not sure like the math behind that, but yeah, I recently learned this, and it's very useful for stuff like this where it's really a struggle to try and, like, I couldn't do a problem like this last time whenever I tried to do the log base change. Well, this would, of course, stem from something like, not actually sure, I'm gonna have to do this off the top of my head, so, like, well, this doesn't have any squares, so I don't think, yeah, there's an odd number, so I would have to do some like weird stuff here. I'm not even gonna bother. You can go look at like the problem I did last time in log base change if you are interested in that, because it was also pretty strange. But Newton's iterative method, if you plug in 2, of course I just showed you earlier, gets it in like 2 or 3 tries. So just it's a great method, and I hope I could help people like discover stuff like that, because it's very useful to use that whenever there's really not much else you can do. So thank you for watching, and have a great day. Bye.